Okay, today we learned about the sum and difference formulas from your laminated formula sheet about trig stuff. We are only looking at two of the formulas today, and those are the sum and difference formulas here at the bottom. I know that's not very close here in the view, but you should have your own copy of that. That's why I had it laminated for you. Please do not get rid of that or throw it away. You will need that till the end of the school year, if not longer. Today, again, we're only doing sine and cosine. This is called the sum and difference. It's used to find exact values on the unit circle, even when we're talking about things that are not on the unit circle. And the reason we would want to do that is sometimes we might not have access to a calculator, might want to be able to do it more quickly, and you will probably use this if you go on to take calculus to simplify some things and such. So there's a lot of good applications. We have three examples to do. Example number one is to find the cosine of 75 degrees. Okay, and as you know, 75 degrees is not on the unit circle, but if I broke it down, I could do the cosine of 30 degrees plus 45 degrees, because 30 plus 45 is 75, and both 30 and 45 are on the unit circle. Now, you would be given this piece right here before you would be asked to do anything, so that's all part of the problem. Okay, to find the solution, we are going to use our sum and difference formulas from our laminated sheet. First, let's establish what u is. U is the first one, and that's 30 degrees, and v is the second one, and that's 45 degrees. I'm going to drop the degrees from here on out, and you can just assume that that's what I'm using until we move on to radians. So for now, degrees. If you look at the formula involving cosine right here, you will notice that in between there is a plus or minus to start with, and then a minus or plus on the other side. All that means is that for cosine, the signs are alternating, meaning if the original one is plus, the new one is minus. If the original is minus, the new one is plus. In our example, the original is plus, so when we write out the formula on the other side, or what it equals, we're going to use a subtraction sign. You can see from the formula that the cosine of u plus v is equal to the cosine of u cosine of v minus sine u sine v. So this part right here is equal to the cosine of 30 cosine of 45, and those two things are being multiplied, minus the sine of 30 sine of 45. And we got all of that from the formula sheet. The next thing we want to do is look at where cosine of 30 is on our unit circle and put that value. Remember that cosine is the same as x, sine is the same as y. So for cosine of 30, that's our x value, and the cosine there is square root of 3 over 2. And the cosine at 45 degrees is square root of 2 over 2. Minus the sine at 30 degrees is 1/2, and the sine at 45 is square root of 2 over 2. Now all we have to do is multiply this out and get a common denominator. Let's start with the common denominator. We have 2 times 2, which is 4, and 2 times 2, which is also 4, so it's already common. So that's taken care of. The other good thing about that, guys, is most everywhere on the unit circle has a denominator of 2, which means when multiplied by another 2, you're always going to get a denominator of 4. So check that out, but that's most likely going to be the case. As far as the top, we have square root of 3 times square root of 2, which is square root of 6, minus 1 times square root of 2, which is square root of 2. And that would be our answer. Several people today asked why we couldn't combine these two, and the answer to that is because we can't reduce this one to be square root of 2 or something square roots of 2, and so they're not like terms and we can't add and subtract them. So that is our final answer. Okay, example 2. Let's do one with sine and radians. So we want to find the sine of pi over 12, which we know is not on our unit circle. We could break that down into sine of pi over 3 minus pi over 4. And again, this would be given to you, so you don't have to know how to come up with that. That's another day, and we're not going to worry about that in this class. Let's go ahead and label our u and our v. Our u is pi over 3. Our v is pi over 4. Excuse me. And this time we'll want to look on our laminated sheet at the formula for sine. So for sine, we have sine u cosine v, so we have sine pi over 3 cosine pi over 4. And remember I said earlier the sign is the same, so if we start out minus here, it's going to be a minus in between for sine. Sine, same, SS, maybe that'll help you remember. And then the second part is cosine u. So cosine pi over 3 sine pi over 4. And after we've taken that straight from the formula sheet, we can find those points on our unit circle. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4 is root 2 over 2. Minus cosine pi over 3 is 1/2. And sine of pi over 4 is root 2 over 2. And as you can probably see, this looks exactly like what we had on example 1, and so our answer is exactly the same. You could work it all out if you wanted, but I promise you, you would get the same answer there. And as you know, the unit circle is secular because it's a circle and it cycles the same numbers over and over again. A lot of times your answers are going to be the same. The only choices you have are things like root 3 over 2, 1/2, and square root of 2 over 2. So there's a few combinations you can get when you multiply those, but don't be surprised when you get very similar answers. Okay, we do have one last example we need to take a look at, and that's example 3, and that's how do we go the other way? So what if we're given the big long piece? How do we get back to the short piece? So this is finding the exact value. As a problem, you might be given something like this: sine of 42 cosine of 12 minus cosine 42 sine of 12. That would be the problem. The first thing you need to decide is when you look at your formula sheet, and this time you're looking at the right side under sum and difference formulas, does this one look more like sine or more like cosine? Remember, cosine has cos, cos, sine, sine, so if they're mixed, it's sine, like what we have. So we have sine, we know that it's that one. Our u is always the first number, so that's 42. Our v is always the second number, so that's 12. The last thing we need to decide here is what should our sign be in between. Remember, for sine, the sign stays the same. So if we have minus here, we have minus there. And we're almost done. 42 minus 12 is, of course, 30. And so we have the sign of 30. Now on your homework, or anytime you're given one that is not on the unit circle, you would stop right there and that would be your answer. However, on this one, it is on the unit circle. So we know that the sign of 30, if we look it up, will be 1/2. And that would be our final answer on this problem. If you have any questions, come and see me. Tomorrow is Pi Day, so don't forget to bring your stuff. The assignment with this is page 404. It's number 8. Numbers 1 through 4, 23 to 24. And 1 through 4 are like examples 1 and 2. And example 3 is like numbers 23 and 24. The last thing I want to tell you is that part B on 1 through 4 is old stuff. You're just going to take it straight from your unit circle, so don't let that freak you out at all.